Another example of being able to solve one of these types of rational integrals, again, not by doing long division, but by doing decomposition. X squared plus 3, x cubed minus 4x dx. Notice that the degree of the numerator is 2, degree of the denominator is 3, no need for long division. Factoring, only worrying about the rational component of it, not the integral. X squared plus 3, we're going to factor out an x, and that's going to leave us with x squared minus 4. And another way to write that is going to be x squared plus 3 over x by difference of squares, x plus 2, x minus 2. And so notice that we have 3 linear terms, which means we're going to have 3 partial fractions. So we're going to have a over x plus b over x plus 2 plus c over x minus 2. We're going to multiply both sides by the common denominator. All right, and we've seen this a few times, so we should be getting pretty good at recognizing whatever it is that was missing, or whatever it is that's missing from the denominator, that's what you're going to have after multiplication. Okay, so, but technically we're going to multiply everything by x, x plus 2, x minus 2 on the left side, all right, which is going to cancel all this stuff out, which is going to leave us x squared plus 3. And here's a pretty easy way to think about this. The denominator of a contains the x. So after we're done multiplying, the x's are going to cancel out, and we're going to be left with x plus 2, x minus 2. Okay? Or if we were to multiply that out, that would just be x squared minus 4. Right? And that might be a little bit easier to work with. For b, we're going to cancel out the x plus 2, so that's going to give us x, x minus 2. And then finally, for the c, we're going to have x, and we're going to cancel out the x minus 2, so we're going to have an x plus 2. And if you don't trust me, what you could do is you could just take x, x plus 2, x minus 2, and notice that this would cancel out with this, and notice we have x plus 2, x minus 2, which is x squared minus 4. All right, so at this point, we need to try to solve for those undetermined coefficients. And we could either create a system, or we could plug in some nice numbers and see if something cancels out or not. All right. I'm going to do the nice number technique this time. All right. Just because it's a little bit easier, I guess, than having to solve a 3x3 system. So an easy number to plug in right away is 0, because wouldn't that get rid of this and this? Okay. So if x equals 0, that means we get 0 squared plus 3 equals a times -4. And then technically we get b times 0 and c times 0. Okay, so notice that this would go away and this would go away. All right, I'm going to erase that because we're going to use it again in a moment. Okay. And then just going through and solving that, clearly we would get -3/4 is equal to a. All right, so we're going to hold on to that, all right, because we're going to need it in a little bit. Another nice number that we can plug in is going to be 2. Right? And so that's going to give us 2 squared plus 3. If we plug in 2 here, that's going to give us 4 minus 4, which is going to cancel. If we plug in 2 here, the b is going to cancel, and then we're going to get 2, and then 2 plus 2 is going to be 4. So we're going to end up with 8c. All right, and clearly, we're going to get 7/8 is equal to c when we substitute back in for 2. All right. And then finally, we can plug in one last nice number, -2, and that's going to cancel out the a and the c, and that'll leave us with the b term. So let me erase this. All right. So if we substitute x equal -2, okay, that's going to give us -2 squared, all right, plus 3. -2 minus 4, that's going to cancel this out. And then this is going to give us b times -2 times -4. So that's going to be 8b. And then finally, that's going to cancel this out. Right? We can finish this by just dividing both sides by 8. And that's going to leave us with 7/8 is equal to b. All right. So at this point, what we're going to do is we're just going to integrate term by term. all right, by substituting our A, our B, our C back in, getting three integrals, and then we might have to simplify it. Okay, so the new equation or the new integral is going to be integral of negative 3/4 over x dx plus, remember b was 7/8, so we're going to have 7/8 over x plus 2 dx. It doesn't really matter because they're both 7/8. X plus 2 dx. And then finally, we're going to have 7/8 over x minus 2 dx. We know that they're all going to be natural logs, all right, because they're all linear in the denominator. So one answer that we could arrive at, 3/4 natural log of x, 7/8 natural log absolute x plus 2, and then another 7/8 of ln absolute x minus 2. And of course, there's a plus c in there, right? And on the examination, I don't have any problem with that solution. Right? However, we probably want to make sure that if MyMathLab or something else, or if you want to match it up to something that's in computer algebra system, we might want to go back and try to make sure that we can put this all as a singular sort of fraction, okay, or a single logarithm. So we're going to rewrite this as negative ln x to the 3/4, and then ln. And if we do the other one, since it's an x minus 2, we can write this as the 8th root of x plus 2 to the 7th. And then similarly, we can have ln absolute 8th root x minus 2 to the 7th power, and then plus c. There is another absolute value in here. Just made it in there, right? Positive in the numerator, positive in the numerator, negative in the denominator, right? And so if we were to simplify all this, one possible answer as a single logarithm could be the 8th root of x plus 2 to the 7th, 8th root x minus 2 to the 7th, divided by x to the 3/4 power plus c. Another way to write this, if you elected to, is to merge these two together, and you get ln of the absolute value of the 8th root of x plus 2 to the 7th, x minus 2 to the 7th over x to the 3/4 plus c. Another possible answer could be if you get a common denominator for this x to the 3/4 and an 8th root. So, and this is probably the answer that they might want, but just showing you that one other possible answer for this could be if this were to be written as x to the 6/8, and then you could write that as the 8th root of x to the 6th. Then finally, you could rewrite this as the ln of the 8th root, just one big old 8th root of x plus 2 to the 7th, x minus 2 to the 7th, divided by x to the 6th plus c. All right. If you wanted to take it another step further, you could actually multiply the x plus 2's together and get x squared minus 4 to the 7th if you were to FOIL it out. So just showing you the number of different ways. So this could be x squared minus 4 to the 7th, just illustrating the multitude of different ways that one could write the answer to this. All right, so it's really tricky when you're writing it with all the radicals and also with the logarithms. And keep in mind that really what we're doing here is just algebra 2 stuff. So it's not meant to be too tricky or difficult, but just illustrating how that does work. Great. So another video, we're going to go ahead and do another one of these types of rational integrals.